All right, so we're looking at section 5.4, page 142. All right, so a problem like this, I want it to be, instead of what we had, it's 1/2 x to the 2/3 equals 2. So the first thing we're going to have to do is to undo this 1/2. We're going to multiply both sides by 2. So now we're going to have x to the 2/3 equals 4. First, I want to undo this down here. If I have this 3 in the denominator of the rational exponent, that means the cube root. How do I undo a cube root? Cube, right? So I'm going to cube both sides. So I'm going to cube this side, and I'm going to cube this side. So now I'm going to have x to the 2/3 cubed. I would multiply these. That's 6/3, which is just x squared. So I undid the cube root, so I'm just left with x squared. 4 cubed is going to be 64. So now to undo the x squared, I have to take the square root. So what's the answer to that going to be? Plus or minus 8. As we talked about in the warm-ups, -8 squared would also work on this problem. Yes?
So I did it kind of differently, but I'm wondering if it would still be an okay method to use. So since you're doing the opposite of it, couldn't you just multiply it by 3/2 and then cube it and then square it?
Yes, but you have to be careful with the plus or minus when you do that. So here's what she's saying, guys. So she's saying that you've got x to the 2/3 equals 4. So in one step, due to the 3 halves. And that's okay as long as you realize that when you take the square root of 4 here, you have to put plus or minus 2. And then when you cube it, because we still have to cube it, then positive 2 cubed is 8 and negative 2 cubed is -8. So yes, that will work. All right, let's look at number 12 now. On this problem, the first thing we'd have to do is subtract our 28. So we'd have 6x plus 10 to the 7/3 equals 128. So now, like Anna pointed out, I could just do this in one step and raise to the 3/7. It is a faster way to do the problem. And that's because if I have 7/3 and 3/7, that would just give me to the first power, which is what we want. What's the 7th root of 128? 2, right? We know the 5th root of 32 is 2. And so the 6th root of 64 is 2. So the 7th root of 128 is 2. So now we have, that's 2 to the 3rd. That's going to be 8. So we have 6x equals -2. X equals -1/3. We should check our solutions because we can get extraneous ones. 6 times -1/3 would be -2. -2 plus 10 would be 8. The cube root of 8 is 2. 2 to the 7th is 128 plus 28 is 156. So you don't have to write it out or anything. All right, let's do this one. First thing we have to do is get rid of this 1/2. So I'm going to have to multiply both sides by 2. Now, I want you to look at this for a minute. What this actually means is I would raise both sides to the 4th power, but I have to stop and think about this. This is the 4th root of x is equal to a negative number. It was okay when I had odd roots and I was dealing with negatives. That's okay. But if I'm taking the 4th root of some number, will I ever get a negative answer? No. So this is going to be no solution. Just like in the warm-ups, we had the problem, the square root of x equals -3, and that was also no solution. All right, let's come down here now. We're going to work with inequalities. So to solve inequalities, we just have to go one step at a time. First thing I'm going to do is subtract our 3. Next thing I have to do is divide both sides by -4. What happens to the inequality when I divide by a negative? It flips it. Let's pause for a minute and talk about why that happens. It's kind of interesting to look at. But if I start off with a true inequality, let's take the inequality, just watch, you don't need to write this down. 1 is less than 3. That's true, right? If I add 2 to both of these, I would get 3 is less than 5. That's still true, isn't it? If I multiply both of these, original, that's true. If I multiply them by, say, 5, multiply that by 5, multiply that by 5, is it still true? So I'm saying then that addition, it's true. Multiplication, it's true. What about subtraction? What if I subtract, say, 4? Subtract 4 from this, subtract 4 from this. Is that still true? Is negative 3 less than negative 1? Yes, it is. All right, now let's say the last thing. So here I said adding 2, it was true. Multiplying by 5, it was true. Subtracting 4, it was true. But now, what if I multiply by negative 1? If I multiply this by negative 1 and multiply that by negative 1, is that true that negative 1 is less than negative 3? So what do I have to do if I multiply or divide by a negative to make it a true statement? I have to switch it, don't I? And so that's kind of showing you that for addition, it's not necessary to flip it. Multiplication, subtraction, but for multiplication or division, it is necessary to do that to keep it true. So that's what we have to do here. When we divided by the negative, we had to flip it. I'm going to square both sides. I'm going to add 1. And there's going to be my solution. And writing that in interval notation, it's going to look like that. I should check a number in here and make sure it works. I always like to do that. Hold on a minute. If I plug in, hold on. If I plug in a number in that interval, like even 0, 0 is not going to work, is it? So we're going to have to do more work with this then. So what's the problem with that?
If it's a negative number, then it'll be negative over the radical.
Right. So 1, would 1 even work? 1 minus 1 is 0. That 1 would actually work, wouldn't it? The number 1 would be okay. But the number 0, then I'm going to get a negative under the radical. So what I have to look at is my domain originally. See, looking at this problem, what is x going to have to be greater than for this original problem? 1. X is going to have to be greater than or equal to 1, just based off of the original problem. So therefore, instead of my solution being from negative infinity to 2, if x must be greater than or equal to 1, my solution then is actually going to have to be from just 1 to 2. It's a very small group of numbers that's going to make this work. So if I plug in 1, it's okay. If I plug in 1.5, it's okay. If I even plug in 2, 2 minus 1 is 1, square root of 1 is 1, negative 4 plus 3, greater than or equal to negative 1, it's equal, so that works. So do you see what I'm saying there? If I have a square root, I've got to look at that original and say what's x allowed to be, and then fix my final answer. All right, let's look at number 14. Cube roots I don't have to be real careful about because there is no restriction. I can take the cube root of a negative number. So what am I going to do to both sides here to fix this? Cube both sides. So when I cube both sides then, I'm just going to get 2/3 x plus 1 equals 36 times 6 is 216. So now I have 2/3 x equals 215. Multiply by 3/2. And I'm going to get 645 over 2. Oops, sorry, I switched this from to equals. It should stay less than. So this is going to be then 645 over 2. And that would be from negative infinity to 645 over 2. And I'm just going to check 0 just real quick just to make sure it works. Cube root of 1 is 1, that's less than 6. So this should be okay. The time we get into trouble is more when we square a radical than if we cube a cube root. All right, let's go down to the last one. In basketball, the term hang time is the amount of time that a player is suspended in the air when making a basket. To win a slam dunk contest, players try to maximize their hang time. A player's hang time is given by this equation. Time equals 0.5 radical h, where t is the time and h is the height in feet of the jump. The second place finisher of a slam dunk contest had a hang time of 1 second, and the winner had a hang time of 1.2 seconds. How many feet higher did the winner jump than the second place finisher? Any ideas on how we could figure this out? What do you think, Zane? All right. Okay, so one of the players had 1 second for his hang time, so I'm plugging that in for t. 0.5, I'm just going to call it 1/2. And then the other person had a time of 1.2 seconds. So what is 1 divided by 1/2? 2. Square both sides. So this first person, who came in second place actually, had a height of 4 feet. The first place person, we're going to multiply both sides by 2 or divide by 1/2, is 2.4. Square both sides. I know 24 squared is 576, so this is going to have to be 5.76 feet. And so how many feet higher did the winner jump than the second place? 1.76 feet higher. What do you guys think about this answer? You think it's a reasonable answer? Do you guys know what the what vertical jumps are for basketball players, like even in the NBA? Any ideas? Seems about right. So this would be 4 feet, so that's 48 inches. This is almost 6 feet. 6 feet I know is 72 inches, so it's like, what would it be? About 70 inches. Is 70 inches a realistic vertical for a person? Not really. We actually looked it up in 4th period because they said that is not realistic, and so we looked it up, and Wilt Chamberlain has the highest vertical jump of any player to ever have played basketball, and his was a 48-inch vertical. So not a realistic problem. They probably should have made this more like 0.8 and then maybe 1 if Wilt were still playing, but he's a little too old to play now. So, all right, but that's okay. We get the idea with the problem.